Assalamualaikum. Alright, in this video I'm gonna show you the definition of derivatives. Right, so the definition is here. You have to memorize this definition. It's not given in the examination. Right, so f prime x is given by the limit as h approaching 0 of fx plus h minus fx over h. And most of the students, when they see this definition, they kind of, oh my, what is this? What the toot is this? All right, so all those questions will be answered in this video. All right, so I'll try to make it easy for you to understand. All right, so let's say we have the first function here. Let's say it is fx. Right, so firstly, if we use the technique of the previous techniques that I've been showing in the previous video, you can use the variable technique. In this case, when you differentiate this, you can directly get 3. But how to get 3 using the definition, right? Meaning to say that how the mathematicians in the ancient century, how they get these 3. So actually they use the definition. All right, so the definition is given by these. All right, so firstly, to use the definition, you have to find the fx plus h. So given that 3x, so the function is 3x, so your 3, all right, x is substituted with x plus h. All right, so that x will be substituted with x plus h. So you'll expand this one, so you'll get 3x plus 3h, something like this. All right, so you're gonna plug into the formula. So this formula is given by these. So we have not substituted h with 0, so you write limit as h approaching 0. So fx plus h is given by this. So 3x, sorry. All right, so you'll have 3x plus 3h. All right, minus fx is given by this function, which is 3x. So you have minus 3x over h. Okay, so now we'll have, all right, so limit as h approaching 0. So take note that we can cancel this 3x with 3x, we'll just left with 3h over h, and then we can cancel this h. You'll have your final answer. Right, so you'll have something like limit as h approaching 0 of 3. But do you have the variable h to be substituted with 0? So no. So limit of the constant function will get that constant value, so that the final answer is 3. So meaning to say, if you have the function fx, so you'll have your final answer as 3 here. All right, so yes, exactly the same as this. All right, but you have to show this using the longer method. All right, so we call this as definition of derivatives. All right, so let's look at the question number 1. Okay, so we have this, what do we call that, x squared minus 3x. So firstly, we have to find the fx plus h. So you substitute the value of x with x plus h. All right, so square minus 3x plus h. All right, so to do this, so you better simplify this, or you better expand this first. So x plus h square will be x squared plus 2xh plus h square. All right, minus 3x minus 3h. Okay, that is your fx plus h. So now you're gonna substitute into the formula where fx plus h is given here, fx is given here, so h is h. Right, so I'm gonna write the formula first. So I'm gonna substitute into the formula. All right, for fx plus h is given by those that expression. So plus h square minus 3x minus 3h. All right, so that one is for fx plus h. Now we're gonna subtract the fx, which is, all right, be careful that we have to subtract the whole thing here. So we are gonna substitute that into the bracket. So put it into the bracket, something like this. So we have everything here over h. All right, so next step is to substitute the expand the negative symbol there. So we'll have limit as h approaching 0 of x squared. All right, I'm gonna write everything here. Okay, so you don't be lazy to copy everything here. You have minus x squared plus 3x. So be careful. Most of the students, they forget to write this bracket. That's why they make mistakes, right? So over h. So now we're gonna see something that we can cancel. All right, x squared with x squared, and we have minus 3x with plus 3x. So please take note that we are left with, okay, I'm gonna write here limit as h approaching 0 of 2x plus h squared minus 3h, because we have already removed this part, all right, and also we already removed this negative 3x with plus 3x. Okay, we are left with that one. So don't forget your denominator, we still have h there. So now we have, all right, so that's your strategy. Firstly, you have to write the formula, substitute into the formula. We try to cancel those terms, you know, those terms that can be cancelled, leaving only terms having h. All right. So please note that all terms having h inside here, so we can what do we call that, factorize that h. All right. So factorizing h will get, all right, so we have not substituted the value of h with 0, so we write this limit. All right, so we'll substitute, factorize, so we'll get 2x plus h minus 3. Okay, the whole thing over h. Now we're going to cancel this h with h, because you know you have the same term at the numerator and also the denominator. So you have not substituted, you'll still write this limit as h approaching 0. So leaving with only 2x plus h minus 3. So now you have to substitute the value of h with 0. So you'll have 2x plus 0 with minus 3. So your final answer will be 2x minus 3. All right, so if you don't trust with your or if you want to check your final answer, you can use the previous technique we've learned to differentiate this one. So differentiating this one, we'll get, all right, you bring down, you copy minus 1, you get 2x, and then you minus 3. So that is the same as your final answer. So bear in mind that you can check your final answer using the techniques that we've learned. All right, so let's move to question number 2. What if we have square root here? All right, so if we have square root, so what we should do firstly, okay, so firstly we have to substitute, we have to find the fx plus h. So the same procedure here, so 2 of x plus h plus 3 minus 1, so this can be expanded to be 2x plus 2h plus 3 minus 1. All right, so now we're going to substitute into the formula. All right, so always write the formula first. All right, so firstly we'll have limit as h approaching 0. All right, so that part, that fx plus h will be substituted with square root of 2x plus 2h plus 3 minus 1, and then we subtract the fx is substituted with this part. So please put inside the bracket, so be careful. So we'll have something like square root 2x plus 3 minus 1. All right, the whole thing over h. Now we are going to substitute we have to simplify that. All right, the numerator. So I'm expanding that negative symbol first, so 2h plus 3 minus 1 minus square root of 2x plus 3 will get plus 1. All right, the whole thing over h. So please take note that negative 1 plus 1 will give you to 0. All right, so we just left with, all right, so limit as h approaching 0 of square root 2x plus 2h plus 3 minus, all right, square root of 2x plus 3 over h. All right, when you have reached this part, so this is the part that you have to know the strategy, where when it involves the square root, so you have to use the conjugate. So the conjugate for this numerator is actually, all right, so you'll have square root of 2x plus 2h plus 3. If you have minus here, so you'll have plus here. All right, that is the conjugate for that term. So square root of 2x plus 3, the whole thing over, so you write the same thing. All right, so 2x plus 2h plus 3, so plus square root of 2x plus 3. All right, this is the strategy that you have to know. So now you have not substituted the value of h with 0, so you're gonna write again that it is limit as h approaching 0. So all right, so what you do is to expand this part, what do we call that, the numerator will become, all right, something like square root of 2x plus 2h plus 3 square minus square root of 2x plus 3 square, right? the whole thing over h, and you multiply, don't not expand, all right? So do not expand the, what we call the denominator. So just write square root of 2x plus 2h plus 3. I really hate this part because it is quite tedious, all right? So, but you must have a lot of exercises to be very mastered about this, all right? And then when we have square root, all right, if you are wondering how do I get this part, all right, so let's say we have, all right, so let's say we have, okay, I'm gonna write, suppose we have like kind of square root a plus square root b, we multiply with square root a, all right, that's minus square root b, all right? So this can be expanded, all right? So you multiply this part, you'll get square root a square, and then you multiply this part, you'll get negative square root ab, and then you multiply this part, you'll get plus square root ab, and then the last part will be minus square root of b square. So this part and this part can be cancelled. We are left with this part only. So that's what I did in this part, all right? So now, sorry, in this part here, all right? So now we are going to simplify that. So please take note that it will become, so limit as h approaching 0. So that part are left is, all right, square root 2h plus 3 minus the one, that one, it will be put in the bracket. All right, so everything in the denominator, you don't expand that one, so you just copy everything. All right, plus 3 plus square root of 2x plus 3. Okay, so now the numerator should be expanded, where you should be simplified. So square root 2x plus 2h plus 3, I will minus 2x minus 3. So again, the denominator will be copied without changing everything. All right, plus square root of x plus 3. So now you are going to cancel the same term in the numerator. All right, so this part and this part can be cancelled. So all right, maybe I'm using another color, it will be clearer for you. All right, that part can be cancelled. So you're left with, all right, so leaving only, all right, limit as h approaching 0 of 2h, the whole thing over h, all right, square root of 2x plus 2h plus 3 plus square root of 2x plus 3. All right, so we're going to cancel the h. All right, remember, if you don't have anything, you don't have the term to be factorized, it's okay, you can directly cancel h. All right, so you're left with, all right, so I'm going to write limit as h approaching 0, so only left with 2 at the numerator, and the denominator are left with square root of 2x plus 2h plus 3. So plus square root of 2x plus 3. All right, so now we are going to substitute the value of h with 0. So you have, all right, 2 square root of 2x plus 3, because this part will become 0, because 2 multiplied by h is 0, it will be 0. So plus square root of 2x plus 3. Students, get confused when it comes to this part. They don't know how to simplify the denominator. All right, so suppose we have like a square root a plus square root a, so you'll get, all right, I'm going to show you x plus s, we'll get 2x. Donut plus another donut, we'll get 2 donuts. So square root a plus square root a will get 2 square root a. All right, so the same goes to this part. If you have square root 2x plus 3 plus square root 2x plus 3, so of course you'll get 2 square root of 2x plus 3. And please take note that these 2 and 2 can be cancelled, so leaving 1 at the numerator. So you have your final answer as 1 over square root of 2x plus 3. All right, so that is your final answer for this one. All right, that's why I said I hate this question, all right, because it's very tedious and very long, but the mark is only 5. But never mind, you just have to know if it involves the square root, you'll always have to use the conjugate to solve the problem. All right, so now let's move to question number 3, where it involves a fraction. When it involves fraction, it's quite complicated, where you have to modify the formula a little bit. All right, so firstly, we have to substitute the value of x with x plus h. So we'll have something like x plus h square over 1 plus x plus h. So expand the numerator, you'll get x squared plus 2xh plus h square. All right, so we'll have 1 plus x plus h. All right, this formula, because it involves a fraction, bear in mind when it involves fraction, you can modify the formula where it will become limit as h approaching 0 of 1 over h, and then you'll have fx plus h minus fx. All right, actually it is the same formula, I just moved that 1 over h apart from the fx plus h minus fx. All right, so now we are going to use this formula inside this question. All right, so I'm writing this. All right, I'm using black color a bit clearer. All right, limit as h approaching 0. So now I'm going to write 1 over h. So I'm going to substitute the value of fx plus h with this part. So this will become x squared plus 2xh plus h squared over 1 plus x plus h minus, so we're going to minus the fx, for fx is given by this function, so x squared over 1 plus x. All right, so now we're gonna, you try to make it one fraction. So to do that, we have to do the cross multiplication, where you have to multiply this part with this part here, and also this part here. So now we'll have something like, all right, so I'm gonna write 1 over h. All right, so you'll have something like, all right, 1 plus x squared plus 2xh plus h squared minus x squared. All right, I'm multiplying this part here. All right, so we'll have 1 plus x plus h. Okay, so the whole thing over, all right, so 1 plus x plus h, 1 plus x. You don't even have to expand the denominator. Right, in this case, right, I'm trying to simplify the numerator. So what I'm doing is I want to expand this part, right? I'm expand this part and also this part, right? I'm trying to expand that. So we'll have something like, all right, 1 multiplied by that, or x squared plus 2xh plus h squared, and now I'm expanding that x, so we'll have x to the power of 3, right? I'm expanding this part, and then this part we'll have 2x squared h, and then this part will have plus x h to the power of 2. All right, so now I'm expanding this part. All right, so I'll have minus x squared minus x cubed minus x squared h. All right, so I'll have something like, all right, the denominator is just, I'm not expanding that, 1 plus x. All right, so now I'm trying to simplify where can be simplified, so x squared with x squared, and next is, all right, I'll still have x to the power of 3 minus x to the power of 3. Other part can be simplified is actually, all right, I think that's the only that can be simplified. All right, so okay, so I'm gonna simplify this. All right, so so limit as h approaching 0 of 1 over h. All right, so I have 2xh plus h squared plus, all right, this part can be combined, so we'll have x squared h only plus xh squared, right? 1 2 3 4. All right, so the what do we call the numerator, denominator is maintained without changing anything there. All right, so now in the next step is actually factorizing the h. So we'll have limit as h approaching 0 of 1 over h. I'm factorizing the numerator, so I'll have something like, all right, h 2x plus h plus x squared plus xh, and the what do we call the denominator is copied without changing anything, 1 plus x. All right, so I can cancel this h here, so we'll have, all right, limit as h approaching 0, and I have 2x plus h plus x squared plus x h, the whole thing over 1 plus x, 1 plus x plus h, 1 plus x. Next step, I'm going to substitute the value of h with 0, so this part will become 0, this part will become 0, and this part will become 0. So I'll have something like, alright, so I'm not writing the limit anymore, so 2x plus x squared, the whole thing over 1 plus x, and that part 1 plus x. Please take note that the denominator can be simplified as, alright, so I have like 1 plus x squared. Alright, so that's my final answer for this type of questions. If you want to check this, you have to use the u over v technique or the quotient rule, right? So alright, so that's the definition of derivatives. Alright, let's try the last question here, where it involves fraction also square root. So firstly, we'll have to substitute the value of x with x plus h. So I'm writing this as, alright, 1 minus x plus h. Please put it in bracket. So be careful, because we change this part here. Right, so this can be simplified as 1 over square root of 1 minus x minus h. Okay, so because it involves fractions, so we have to modify this formula a little bit. So we'll have limit as h approaching 0 of 1 over h of, fx plus h minus fx. Okay, so try to use the formula. Alright, so limit as h approaching 0 of 1 over h, the whole thing over, alright, so I'm writing 1 over square root of 1 minus x minus h minus 1 over square root of 1 minus x. Alright, so the next step is to do the cross multiplication, because we want to make it as a one fraction here. So we'll have something like, alright, so limit as h approaching 0 of 1 over h. So we'll have, what do we call that? 1 over, alright, square root 1, I'm multiplying that part, we'll get 1 minus x. That part will give you 1 minus x minus h, the whole thing over, right? You don't expand the, what do we call that? The denominator. Okay, well, we have this part and we can't do anything. The goal is to cancel this h here, but where the h at the numerator? So to do that, again, you have to multiply with the conjugate of the numerator. So in this case, the conjugate will be plus there, all right? So 1 minus x minus h. So the whole thing over square root 1 minus x plus square root of 1 minus x minus h. Okay, so when you have this, so I'm trying to multiply this, all right? I'm trying to multiply this part of this part, and also this part of this part. So we'll have something like, all right, so limit as h approaching 0 of 1 over h. Okay, so I'll have, right, square root of 1 minus x squared, something like this, minus square root of 1 minus x minus h squared. Alright, so I'm writing this part first, so we'll have square root of 1 minus x minus h, square root of 1 minus x, and then I'm writing this one, please put in the bracket, square root of 1 minus x plus square root of 1 minus x minus h. Alright, because this one is a term, is two terms there, so you have to put in the bracket. Okay, so now I'm simplifying the, what do we call the numerator first. All right, so 1 over h. So this can be simplified as, all right, so 1 minus x minus, the whole thing is 1 minus x minus h. I put in a bracket. So this part, the numerator should be copied without changing anything. All right, minus h, square root of 1 minus x, and then we'll have in the bracket square root of 1 minus x plus square root of 1 minus x minus h. All right, I hope you still can follow this. Yes, it's quite tedious here, but you know, with a lot of exercises, inshallah, you can do this. All right. So now I'm expanding the, what do we call that, numerator. All right. 1 over h. All right. So I'm writing 1 minus x minus 1 plus x plus h. All right. So we will have 1 minus x minus h, square root of 1 minus x, and then put in a bracket, square root of 1 minus x plus square root of 1 minus x minus h. All right. So now you're gonna cancel this 1 with 1 because we will have 1 minus 1, and also you can cancel negative x with plus x. So leaving with only h. So I'm writing this. All right. So limit as h approaching a 0 of 1 over h. So you just have h at the what do we call the numerator. Now we write everything in the denominator. So 1 minus x minus h, square root of 1 minus x, and I put in a bracket, 1 square root of 1 minus x plus square root of 1 minus x minus h. Okay, so now we are cancelling this h here because they are the same term at the numerator as the denominator. So we are left with limit as h approaching 0. When we cancel this, we get 1. So 1 over square root of 1 minus x minus h, square root of 1 minus x, and I will have this part in the bracket. Please don't forget the bracket. So 1 minus x minus h. Alright, so now we are substituting the value of h with 0. So this part will become 0, and also this part will become 0. So we will have something like 1 over, alright, so square root of 1 minus x, square root of 1 minus x, and then you have the 1 in the bracket is square root 1 minus x plus square root of 1 minus x. Okay, so you have to simplify this. Alright, this is quite challenging where you have to know the basic of index. Alright, so when you have square root x multiplied by square root x, alright, so let's say, alright, I'm putting it as square root of 1 minus x squared. Alright, and then I'm adding these two terms here. You can add together, you will become 2 square root 1 minus x. So now I'm trying to, what we call, multiplying this part together with this part. So this will be 1 over 2, alright, square root of 1 minus x, because this is the power of 2, this is power of 1, so it will become to the power of 3. So that one will be 1 square root of 1 minus x to the power of 3. So that's your final answer for this part. So this is the definition of derivatives. All right, so again, I would like to remind you that you have to memorize the definition because it's not given in the examination. So please memorize this yellow box here, and you know how to use it, and you can always check your final answer by using the 5 techniques of differentiation. All right, and do a lot of exercises. Inshallah, you can do this. Thank you for watching.